Alright, looks like we're live. Hello everyone and welcome to yet another recreational programming session. So let's make a little bit of an announcement and officially start the stream. So just a second. Not red car, but red circle. Live on Twitch. And what are we doing today on twitch.television? Today we're coding a snack game. That's right. So let me actually give the link to the Twitch channel, twitch.tv/tsoding, and I'm gonna ping everyone who's interested in being pinged. And there we go. So what it's all about. Recently for Porth, the programming language that I'm developing, we implemented a very interesting feature, and I wanted to test that feature out in like more or less substantial application, right? And I was thinking what to implement, and I thought that maybe implementing like a console snake game, right? Snake game would be like a, you know, sophisticated enough example to actually test out the feature. So, and that's precisely what we're doing today. Hello everyone, welcome. How are you guys doing? So you can find the source code of this thing in the chat if you're watching live, or in the description if you're watching on YouTube. So let's take a look at the feature that we implemented on the previous stream. Actually, we started to implement it on the previous stream, but I implemented it off screen. So yeah, let me see. So I think I already fetched everything. And the only thing I need to do, I need to bootstrap my compiler. Right, so let's actually go into the README. Where's the bootstrap instructions? So we're going to be using Fsntl today because it's fast. So the next thing we need to do, we need to change the permission of the executable, and now we have an executable file of the compiler. So we bootstrapped that executable file from the assembly files that come with the language itself, right? So they're quite big, and it's kind of like tedious to actually keep them in a repo because they're so huge, and Git is not really good with huge files. So I'm still thinking how to maybe separate the like bootstrap folder and the actual source code, but I'm not quite sure how to do that yet. So for a while, I'm going to just keep these things in there. All right. So, and after that, I think I'm going to go ahead and compile the compiler, right? So I'm compiling the compiler. And there we go. I have an executable of the compiler, which can compile itself, and we can even confirm that. So I can do something like porth.porth. There we go. And as you can see, the compiler is compiling itself. So we've got a couple of subs. Let me take a look at them. Jan18383, thank you so much for 3 months of Twitch Prime subscription. Thank you. And welcome to our Epic Porth Club. That's right. And Iguduk subscribed for tier 2 for 30 months. My God. 30 months. Thank you so much for such a long and generous subscription. And we also have a couple of subscriptions. Nico Red H, thank you so much for 4 months of Twitch Prime. And Chiroptical, thank you so much for 31. Another OG of the channel of tier 1. Thank you, everyone. So the feature we recently implemented is LED bindings. So let's take a look at them. So let's do hello.porth. And let's introduce the entry point, right? So essentially, Porth is a stack-based concatenative programming language. That means that by like providing some sort of numbers, you actually push numbers on some sort of a stack, and then you can do operations on the top of the stack. For example, plus takes 2 numbers on top of the stacks and sum them up, and then you can print this entire thing, and that will take the top element on the stack and print it and remove it from the stack. And that results in this sort of like reverse Polish notation. But it's kind of like difficult to program it at first, but you just have to get used to it, like with Rust, right? So, we can try to run this entire thing. So let's go ahead and do that. So this is going to be hello, and I forgot to save this entire thing, right? So hello, and let's just run it. And as you can see, it printed 3. So you can also do some manipulations on the stack, right? So if you just do print, it will print first 2 and then 1. So we'll see something like 2, 1, as you can see. And there's an operation that swaps elements on the stack. and as you can see, it prints 1, 2 if you swap the elements on the stack. So we have some sort of words to manipulate the stack. So the amount of words to manipulate the stack is actually quite limited, and we got those words from Forth. We basically inherited the stack manipulation words from Forth, and I personally find those words kind of limiting. Quite often I don't want to think in terms of Forth words like swap, rotate, duplicate, over, like to dupe, to over, and stuff like that. It's like basically writing using this word turns like a regular programming task in some sort of like a puzzle, right? To do anything, you just literally have to solve the puzzle, and it's quite tedious. Even though I can do that, I implemented an entire compiler in this specific style. Right, as you can see, like I have a lot of shit that like uses this like dupe and like swaps and stuff like that. Like I implemented the whole thing in this entire style. Even though I can do that, I still find it quite tedious. So I came up with a different way of manipulating the stack, and that way is basically let bindings, let AB. So essentially what it does, it takes the amount of names in this list and removes this amount of elements from the stack and pushes those elements into the return stack, into the second stack. And now within the block, you can access these elements by using their corresponding names. So if I put A, it will push 1 onto the stack. Right, so and then I can print this entire thing. And if I put B, it will put B onto the stack. So here we'll print 1 and 2. There we go. But I can actually do that several times, right? I can just print this entire thing several times. And basically I can sort of directly access the elements on the stack, which makes it quite convenient. And in fact, I can access as many elements as I want, right? So I can have A, B, C, D, B, C, D, right? And I can do that in any order I want. I can just like go ahead and access those things. How many words, like how difficult would it be to write something like that in Forth using the, you know, Forth operations? What about like several words in here? What about like E? Right, so now like I don't have to think in terms of like these words and solving puzzles. I can just say, okay, let's like refer to these elements on the stack directly and just shuffle and like do something with them directly. So that's basically what I implemented, let bindings. So they worked quite well. I already started to use them within the compiler, right? For example, here is the function that prints the location. It takes the pointer to the location and file descriptor, and basically I just bind them to their corresponding names and I just use them directly. And that's quite useful. Another, like probably the most interesting example is bind table reverse. Essentially it uses these things quite heavily, so it binds the input parameters and some other stuff, and in the loop it actually has like nested let bindings, and here it like swaps elements and whatnot, and it's actually way more pleasant to work with so far, but I'm not sure yet. So there are some drawbacks with using this construction, and I want to kind of explore this construction a bit more, right? And that's why I want to like write more or less substantial application using these let bindings. So, and that's essentially what we're doing today. That's essentially what we're doing today. So, okay, let's go. Let's write a file called snake.porth. I probably want to remove hello. Snake.porth. std.porth. So it's going to be basically like you know, grid-based snake in the terminal, and I want it to be more or less interactive, like directly interactive, kind of similar to Game of Life. So let me actually show you Game of Life. So this is Porth and examples Game of Life. Or as you can see, it basically updates itself like, you know, in real time, but you cannot really interact with this entire thing. But I want my snake game to be interactable. When I press like WASD, I want to control the snake and it will move around. So we probably won't be using incursives, so we'll have to do like direct manipulation of the terminal, or maybe not, I don't know yet. We'll see how it goes. Though I don't really need to like super complicated capabilities of the terminal. What I need to be able to do is just to redraw the screen, and also disable the echo, right? So when the user presses the key, I cannot see the keys that the user is that I'm pressing, right? And I also don't want the terminal to wait until I press enter, right? Because there is some sort of like canonical mode for the terminals, right, in which like you can type, and the read syscall does not return unless you press enter. So as far as I know, there's some ways to disable all of that. We'll see how it goes. And like maybe for now we're gonna use something like STTY, which basically like sets up the terminal, like it disables echo and some other stuff like iCanon, right, and that later will make our game do that for us. We'll see how it goes. I'm not sure yet. So let's write a simple hello world. Let's write a simple hello world. So this is going to be puts, and I'm gonna write the snake.porth. The snake.porth, and as you can see, it says hello world. So since it's a grid-based game, we need to know the size of the grid. We need to know how many rows do we have. Right, how many rows do we have? I think we're gonna have like around maybe 10 rows, who knows? And columns. So I don't want to use the same amount of rows as the columns because like it's super easy to confuse and introduce mistakes that will be caught much later. Let's actually have amount of columns like bigger, so it's gonna be like rectangular thing. All right. So, and just to like get the estimate of the size of the screen, let's actually print the entire thing, right? So I'm gonna do something like dupe rows. I'm gonna drop this entire thing, 1 plus, dupe calls, and then something like this, 1 plus. And in here, I'm just gonna print dots. So this is puts, and at the end in here, probably even somewhere here, I'm gonna print the new line. Right, so this is roughly gonna be our screen, and let me take a look at it. So it didn't work because this thing has to be a boolean, so I forgot an operation, and we have unhandled data, so it's somewhere here. There we go. So this is roughly how it looks like. It looks rather square, not gonna lie. So maybe we can make it something like 20 then. Yeah, to make it look like a square, but it's not really square, right? It's because of the font that we're using. Okay, so I don't know, maybe we're gonna just create something like display, which displays the current state of the game. So I'm gonna just move this thing in here, and I'm just gonna say display. So every time we want to display the frame, it's gonna display the frame. So it would be also nice to keep track of this like position of the player, right? At least for now. So to keep track of the positions, I want some sort of a structure that represents the point, that represents the pair of the numbers. So let's define some sort of a point, right? So this is going to be const point. So we're going to have x, y, or row and column. I'm not quite sure yet. So let's actually have x and y. So x is going to be integer, and y is going to be integer, and the size of the structure is going to be essentially, oh yeah, I have to use offset, of course, and here is going to be reset. So that way, if I add more fields into the structure, right, if I add more fields in the structure, it will also increase the size of this entire thing. All right, so let's actually allocate the memory for the player. So this is the player position, and this is going to be size of the point. Interestingly enough, I want to be able to sort of like take the pointer to a point and spill its content into the stack, and vice versa. If I have like two numbers into the stack, I want to quickly save them into a point in the memory, right? And I want to have something similar to @str and exclamation mark str, which basically like @str essentially takes the element on the stack. It takes the pointer to the string and spills that string into the stack, and this thing does quite the opposite, right? So let's actually implement similar sort of like macros, but we don't have macros, we have procedures. So maybe in the future our language is going to have like automatic generation of such like accessors, but I don't know how to exactly to implement that yet. So @point, right, so it's supposed to read the point, so it will accept the pointer, right, into the memory, and it's supposed to return two integers, x and y, right. So the signatures are rather small. Let's actually keep it like this, right? So that's the pointer to the point, and that's the integer. And so what are we doing in this thing? So I suppose I'm gonna do something like p point x pointer plus read it as an integer and then y. So that's how you spill it onto the stack. And using let actually kind of makes it super easy. Because without the let, right, without the let, you would have to duplicate this thing. But after you read something on the stack, you already have something on the stack, so you cannot easily like duplicate it again, because the original pointer is behind the new value you put in here, so you had to do over. Right, so you have to do over, you're kind of forced to do it like that. So, which like makes you like think too hard about how to code all of that. And furthermore, what if we had z, right? What if we had z, and how would I do that? Because there's no really over that one element over that one. So how would you do that? So you would have to do something like swap, right? So you duplicate here, you swap it in here, then you duplicate again, then you swap it again. And you see, you have to constantly like think about that. Like coding even a simple thing turns into like puzzle solving. So maybe for some people it's great. And I do understand why Forth is doing that, because it's actually quite simple language. So this kind of set of words can be implemented pretty much for any platform. And yeah, but I don't know, I just like don't enjoy this style of programming. I get it, I do get that style of programming, but it's just like not for me. And I coded in it for quite some time, so I sort of formed a pretty good opinion about it. So yeah, I rather prefer like doing things like that. I still like concatenative languages though, right? So, but I just don't like how Force does that. So, and in this case, it would look like this, right? 1, 2, and there we go. So, and you don't even have to think about that. You just bind that thing into the variable, and you just like, yeah, you spill it onto the stack, and it just makes it so much easier. All right. Okay. So. Let me see if this entire thing compiles. It seems to be compiling, and let's define a procedure point, which accepts 2 integers and the pointer into which I want to store them, and it's probably not going to return anything, right? And let's see how would you implement something like that. All right, so I think, again, I can just, you know, bind all of these things like so, right? And then I can do x, p, point x pointer plus, and save it as an integer, and then y, save it like that. There we go. So that was super easy. I didn't even have to think about that. So really didn't even have to think about that. So now we have a way to like spill point on the stack and just gather it from the stack as well. All right, so let me see. So if we have a point in here, memory, so we already have a memory allocated for the player, so I'm probably going to use that. Okay, let's assign 69 for 20 into the player, right? So this is the player, and I want to just do something like this, point, right? So I'm taking the point, and that worked. And at some point, I just want to spill that thing back and print it twice, just to see what's going to happen. And it printed for 20 and 69, exactly what I expected. Okay, that's actually pretty cool. So that thing kind of works. That thing kind of works. So interestingly enough, now, so let me see. When I'm rendering the display, can I detect that I'm currently looking at the player? Right, if you know what I mean. So this is basically, okay, so this is the row and this is the column. That means this is y and x. And then I can take the player, right? I can spill the player onto the stack, and I can have px, py, right? So I have px, py. And we can have a sort of a condition in here. If px equal x and py equal y, right, so this is going to be length, and we can do something like this. We're going to be drawing it like this, right? So that's the player. Otherwise, we're going to be using just a dot, right? There we go. So now we can detect that we're currently rendering the cell where the player at, and just like draw that slightly differently. Okay, so there's a plus, but oh yeah, this one is rather interesting. Yeah. So let, there's one drawback with let. It's basically, it consumes the elements, and if you want to sort of retain some of the elements in here, you have to push them back, right? You have to push them back in the same order, which is kind of like weird. Like I was suggesting that maybe we're going to have two kinds of lets, like let plus and let minus. Like let plus basically does not remove the elements, and let minus removes the elements, but I'm not sure yet. I think I'm not going to use the notation of let plus and let minus. I think I'm going to use the notation of like, I'm going to completely replace the let keyword with two new keywords, something like take and pick. So take removes the elements from the data stack, and pick doesn't remove the elements from the data stack. So we have two use cases: when you want to pick into the stack, and when you want to take the elements from the stack. So, and in this particular case, it's kind of weird because you want to pick into y and x, but you want to take px and py. So maybe in that case, you're going to have like a nested pick and take things, but we don't have that yet. So, and this is precisely why I'm implementing this thing, because I want to like figure out what's needed. Right. So, okay. So if I try to do that, and I never actually try to display the entire thing. Okay. So here you can see our player. So the player is at 0, 0, and here it is. So now we should be able to set the player to, like, say 5, 5, right? So this is going to be the point, and here is the player. How about that? So yeah, we can put the player in different places, and that actually works. And it's even super easy to, you know, assign the new position and just like render everything. Is let binding inlineable? This is a good question, and the answer is yes. It is in fact inlineable, which is kind of interesting. So we can probably inline it. Yeah. The reason why it's inlineable is because it's relocatable. You can easily relocate this thing anywhere you want, because it pushes the data onto the return stack at, like, in here, and removes the data from the return stack in here. So it just doesn't care where you put that thing, which is amazing. So all of that is inlineable, and we can actually make these two things inlineable as well. And as you can see, it works. As you can see, it works. Is it not cool? Have you developed a graphical library for Porth or CLI based? Like, Porth doesn't really have any libraries though, but it's going to be completely CLI based. Will we make an AI for Snake? No. All right. So the next thing I want to do, I want to be able to control the snake, right? So when I like press WASD, W-A-S-D, it will go like in different places. So let me try to see how we're going to approach all of that. So, but I need to be able to get the input from the users. So I probably can do that using a read syscall, right? So, but to have a read syscall, I need to have some sort of a buffer into which I'm going to be reading all of that. So let me see. Let's allocate maybe memory. Maybe it's going to be a local memory. Input size of, I can just like have 1 byte, right? So I'm going to allocate 1 byte. Oh, by the way, recently I implemented, so even if you allocate 1 byte of the memory, it's going to be aligned at 8 bytes anyway. So in reality, it will allocate 8 bytes in here, just to keep the stack sort of aligned properly. I don't know why I need to do that, but I want to do that just in case, because I heard that at low level, it is important to keep the memory aligned in a certain way. Like for some platforms, it is like absolutely necessary, because otherwise you won't be able to read any data from it. And on x86 64, it just like makes the entire thing faster. And like just in case, I align these things by like 8 bytes. Not sure if it's really necessary, but I just do that just in case. I wonder if I even have that somewhere in the code, if I can show that somewhere in the code. Let me actually see. Align, yeah, there we go. Yeah, so in here we take the size of the memory that you're trying to allocate, and essentially we're just like rounding it up to like something that is divisible by 8, like this. Not sure if it's a right way to do that, but it's one way to do that, I guess. So, and I really like how in stack-based language, like this expression looks so nice. Right. So you just like sequentially perform some mathematical operations on the sides, and then you just like use it either to allocate local memories or global memories. And of course, in here we also use like LED bindings. All right. So pretty straightforward, pretty easy to read. Okay, so read. I don't remember how, like, what are the arguments of the read. So let me find proc read. So here we have an integer. So the arguments in the syscalls are in a reversed order. So that means this one is the file descriptor, this is the pointer to the buffer, and this is the size of the buffer. So right now we have like one input, and the input is going to be std_in, and I'm going to just read this entire thing. And I probably want to maybe handle if it was successful or not, or maybe not, maybe I don't care. Okay, so I'm gonna just do something like that. So we set the player to 5.5, we displayed the screen, and we're just waiting for the input from the user. So that's essentially what we're doing. So I'm not gonna run this entire thing because compilation mode is not really great for reading the user input. And I'm gonna just run the snake from here. So as you can see, it printed the entire thing, and now it waits for the input. But as you can see, it doesn't stop if I type more than one character. So it waits for the enter. And this is one of the problems that we have. And as you can see, the rest of the input is like passed to the bash, and bash doesn't know how to interpret this entire thing. So it's kind of like, I really wanted to like react immediately, right, after I press a single key. So to do that, we have to change the mode of the terminal. So as far as I know, the mode that we care about is non-canonical mode, right? So we have to disable a canon. Right, and after that, the terminal is not going to wait for me to press the enter. So if I do something like snake, as you can see, I can just press one character like T, and as you can see, it instantly returned, right? So it instantly returned. But at the same time, it also printed T, and I want my game to be interactive. I don't want to see the characters that I'm actually like pressing. And as far as I know, the sort of like second thing I want to disable from the terminal is echoing. Right now, if I try to type something, you won't be able to see that. So you see, as you can see, I'm typing and you can't see that. So, but at the same time, I can just blindly type snake, and in here I can press T yet again, and you didn't see any T. Right, so, and as you can see, but the terminal is in this busted state. And by the way, if you accidentally get your terminal in this busted state, you can always blindly type reset. I just literally blindly typed reset and press enter, and it will reset the whole state of the terminal, and everything's fine. So basically the state of the terminal we want to get it to is non-canonical one and no echoing. And in that state, we can work with our game, right? We can read the character by character. We can also yeah, and we cannot see the input from the user. So it would be ideal if the game did all of that for us when it starts, and also like enabled everything back when it stops. But I don't really want to focus on it right now because I really want to focus on the game itself. So for a while, we're going to do this thing manually, and then at some point I will just figure out how to do that from within the game. Of course, this is not portable because like different terminals like operate slightly differently, and that's why we have things like termios and curses and stuff like that. But I'm learning things. I want to see how the things work like under the hood. So I just want to have fun. So yeah. Anyway, and how am I going to figure out how all of that works? We can try to basically strace this entire thing. I can do like strace and just see what syscall it's calling. It just calls ioctl a bunch of times. Yeah. It just literally calls ioctl and just like gets probably the current state and sets up. Yeah, okay. So maybe we can do the same thing as well. But ioctl also hides a lot of things in here. Maybe, I mean, strace hides a lot of things. Maybe we can have some sort of flag that shows what the hell is going on here. Though it actually literally shows what is going on. All right. Yeah, I need to understand how to interpret this entire thing. But anyway. Right, so that's going to be the plan. Didn't even know that's possible in the terminal. Everything is possible in terminal. A lot of things are possible. Hello everyone. How's it going? How's it going? Yeah, memory alignment can bite you in the ass. Yes, I know that. I have a pretty scarred ass from all of the bites. I don't get it. Then why is the byte the smallest addressable unit and not int32? That's a good question. Maybe because we store we have a lot of data that needs to be processed byte by byte. For example, like text, right? So essentially, if you have a text and you load it into the memory, quite often you want to address it byte by byte. And if you're working on a hardware where it is not really possible, you're going to end up with reading like a word and using bit shift operations just to extract individual characters, which is not particularly convenient. So that's probably why a lot of hardware just like allows you to still address things by bytes and not by words. But this is just speculation on my side. I'm not really that experienced of a low-level programmer to actually know the reason. So, but yeah, I think this is the reason. So if it's not, just correct me. Does anyone have a tutorial on how to use Emacs like that? You don't need a tutorial, just pick any text editor and just like use it to write code. Don't learn editors, learn how to code, write code. That's what makes you a programmer, not the text editor. Text editor doesn't make you a programmer. It's just a program that allows you to input data into the computer that's going to be addressed byte by byte. So, all right, so let's continue. Alrighty, so let me see. We probably need to organize some sort of a loop, if you know what I mean, right? So let me see. So maybe I want to have something like memory quit, which is going to be size of a boolean, which is 8 bytes anyway, right? So I have a lot of things like size of integer, size of boolean, size of pointer, and all of them are equal to 8. But I just use their names to indicate what sort of type I store in that memory, because we can't attach types to memories in port yet, right? We can't do that yet, but we'll be able to. While quit boolean L0, I'm gonna do it like this. So I probably want to initialize the player up front, and then in here I'm gonna be displaying everything and then waiting for the user input, right? So that's what I'm doing. Oh shit, if I want to have like an interactive game, I also need to mark the standard input as non-blocking. Right, because I want to be able to like render frame by frame, and if on the current frame the user didn't actually press anything, I want to continue like the state of the game. So this one is going to be interesting. So I think you can also use ioctl to mark stdin as non-blocking, and then read will just return e again. I think it will return e again in case of non-blocking, and then you can try again, but we'll see. Anyway, so here is the read, and then what we can do, we want to just check what was the input. So I'm going to take the input and read it as 1 byte, right? I want to read it as 1 byte. Might as well even like bind it to something like CMD, right? So here is the CMD, and if the CMD turned out to be S, right, I'm going to just move down. I'm going to move down. But the question is how we can do that. So it's going to be player down. So let's implement this procedure, player down. So in here, what I need to do, I need to take the player and spill its positions onto the stack. So this is going to be X and Y. right, and in here, so to go down, right, to go down, I need to increment its y, right? So again, I'm going to keep x as it is, and then I'm going to increment its y by 1. And after that, I'm going to save everything back. That is not bad, I gotta tell you, right? So I can even like maybe do something like this, right? So I spilled the player into the stack. Maybe before it was a little bit better. Then I described how I want to modify that data, and I save it back into the player. Isn't that cool? I think that's pretty cool, actually. So yeah, let binding is actually kind of like useful in these specific situations. Not in all of the situations, but in this specific situation, they make the code a little bit more readable. All right, and everything seems to be compiling. So are we in canonical mode, non-canonical mode? STTY, STT. It's such a funny command. STTY. Anyway, I'm sorry. Non-canon and echo. There we go. And I'm gonna create the snake. And then, as you can see, I can now move down. How about that? That's actually pretty cool. I can move out of the entire thing. But as you can see, it doesn't really redraw the you know, the screen, which is not really what we want. I also want to be able to quit with Q, so let's actually quickly implement that somehow. Right. Else cmd q, right, and this one is going to be essentially false, quit boolean, right, that way it's going to work. Unclosed block, really? Oh, this is because this has to be like this. Okay, so, yep, and then I can press Q, and, it didn't exit. The fuck? Very interesting. So why it didn't exit? Disgusting. So I pressed the Q, but when it was... Yeah, it literally didn't exit. Quit? Oh, I see. Oh, I see what's going on, because quit was never actually zero initialized, and it's just like contains bullshit stuff and not actual boolean. Okay, let's actually assign it like in a global memory where it's guaranteed to be zero initialized. And I guess that's it. Maybe all of this memory is going to be global ones, because why not? Right, why not? There's nothing wrong with global variables. Trust me. I'm a professional software engineer. Trust me. Okay. So let's do something like this. Unknown word player, and did I just... Oh, okay, so there was a reason why I put it up there, so some of the other functions can access that. Okay, so that explains it. All right. Okay, and then I press Q, and it still doesn't work. I'm really surprised what the hell is going on. So is that because it's not really Q? Whatever. Not really sure. Oh, because it has to be... Oh my god, I'm sorry. God damn it. Oh! Alright. So, you know, programming is hard. Don't judge me. Programming is hard. Okay, so if I press Q, now it exits. Okay, so that's fine. Now we can go down and stuff like that. So essentially, what I want you to do, I want you to redraw the entire thing, right, like in Game of Life. So let me reset the terminal, and this one is going to be example goal. And as you can see here, we're actually redrawing the terminal. So the way we do that, we're using the special commands, like escaped ANSI commands. Goal.porth. Right, there we go. So that's basically what we do. And we already even like use rows and columns, right? You start the escape sequence, you put like these brackets, and you basically explain how many characters left and up you want to move the cursor, and you just move the cursor there. And since like I'm literally using the same names in here, I might as well copy paste this entire code into the snake. That's actually very epic. So what I do display, but maybe not really display, because I want to kind of do it here. Right, so I displayed everything, I read the user's input, right, read the user's input, and then went back, and I'm going to redraw it yet again. So that way, I think it's going to be a little bit more interactive, hopefully. STTY, where is my STTY? canon echo snake, and I can move down, and as you can see, yeah, I'm moving down. So, and it like basically redraws this specific region in here. There's a bunch of like garbage around this entire thing, but it's fine. It is fine. All right. Cool. So let's actually do the rest of the things. So if the command is W, we want to do player up, right? So this has been the player up. The next one is A, player left, and D is going to be player right. Cool. So player up, we don't have player up. Let's go into the definition of player down, and let's implement player up. So in case of up, we just have to subtract this entire thing. In case of left, we are subtracting x. In case of right, we're adding x. There we go. So unclosed block, and yet again, I forgot to put some things in here. Okay, so where is the unclosed block? Okay, so I have to put these things. So there we go. Okay, so, and now I can move around. How about that? So almost 1 hour into the stream, I have a thingy that moves around like that. Isn't that epic? That's pretty cool. All right. So we have a subscription. Shenara, I hope I pronounced your nickname correctly. Thank you so much for a tier 1 subscription. You for a subscription, by the way, and welcome to our epic Apport Club. Look what we can do. Oh, that's epic. Can you Python do that? I don't think so. Alrighty. So, but this is not really what we want to do, right? In reality, I want to have like a steady FPS, because right now, the entire event loop, so to speak, because we organized event loop, the entire event loop blocks every time we're waiting for the user input, right? Which makes it not suitable for JavaScript developers. Right. Anyway, so we need to do something about that. We need to mark standard input as non-blocking. We need to mark it as non-blocking. I don't remember how to do that, so we'll have to Google it up. So Linux stdin non-blocking. How do you do that? How do you do non-blocking console IO in Linux and C? Okay. We'll see, we'll see. You have to use Fcntl. Very interesting. So, all right. So there's a lot of stuff in here, but I think I want to go Fcntl route, because that looks pretty cool. So essentially, here's the 0. If I understand correctly, this is the file descriptor. We'll have to get the current sort of state of the file descriptor and add non-block, right? We'll have to add non-block and then set it back. Interesting enough, I think I already have non-block in the standard library. Do I? Do I not? Block. Okay, I don't. All right. So that's fine. We can easily implement all of that. And Fcntl, as far as I know, Fcntl is also a syscall, right? Is it a syscall? I think it's a syscall. Performs one operation described. Okay, Linux syscalls. Let's take a look at Linux syscalls. It's taking some time. I don't know why. Fcntl. It is a syscall. All right. So you have to provide the command, and then you have to provide the argument. So it depends on what you set in there. Depends on what you set. All right, so let's actually implement the wrapper for Fcntl. I'm going to do that right in the snake, and then I'm going to move that into the standard library, Fcntl. And in here, we are accepting what? We are accepting the file descriptor, right? So this is going to be fd. Then we are accepting the command. So my laptop is going crazy yet again. I don't know why. Chromium is taking up too much resources for whatever freaking reason. So I'm gonna just like put it like that. And this one is going to be the argument, right? Not always you need an argument, but we kind of don't have optional things in procedures yet. Maybe in the future we're going to have like some sort of like variadic stuff. We'll see how it goes. All right, and in here I'll have to do maybe syscall, and here we accept 3 arguments. Sys Fcntl, and in the standard library, sys Fcntl, here it is. So we do have this entire thing. So I'm actually going to remove that, because usually I write wrappers like this, right? So, and then this thing should return an integer. Usually syscall returns an integer to indicate the error and whatnot. Okay, so I'm gonna actually put this thing in the description as a references, because that's literally what I'm using for this entire stuff. How to make stdin non-blocking, right? So, and that's literally how you do that, non-blocking. We're gonna need some kind of like a couple of constructs in here. We'll need to know what is fsetFL, fgetFL, and O non-blocking. And I think that is basically it. So let me write a simple C program where we're gonna yoink all of those things. Right, so that's gonna be like that. So this is gonna be void. And I might as well just like take this thing. Okay, so, and we don't have any of them because we probably need to include Fcntl, some of the headers in here, right? So that's what we'll need to have in here. All right, and let me see. So here are the things. I can even go further and just like literally write port in here, so I can easily copy paste the output to the standard library and whatnot. There we go. So yep, I can now take this entire thing and literally copy paste it in here. Easy. Easy. So that's how we yoink stuff from the standard library. Who needs writing the source code when you can just like literally generate it? Okay, so we need to take this thing, right? It's going to be, so the argument is going to be 0. The command is going to be get fl, and the file descriptor is going to be stdin fcntl, and this thing is supposed to return, okay, so it's supposed to return something to which we're going to add o non-block, right, or, and then this is where it gets interesting. So we'll have to essentially set that as fsetFL to stdin, and then call Fcntl again and drop it. All right, so that actually fits into the, into the stack-based language quite well, I would say. Maybe not. It's kind of hard to tell. We can maybe realign everything like this, right? So here is the first argument, right? Here is the first argument, the second one, and yeah, so that should work, I think. That should work. That should work. But though it's going to be kind of difficult to see if it like worked or not, unless we actually handle the drop, right? So let me comment out this entire thing, right? And in here, we're going to do the following thing. If this entire thing turned out less than 0, we're going to fail. Error. Read command failed. Right. And then we're going to exit with non-zero exit code. So, yeah. If everything is, blocking, is everything blocking, this error should never happen, right? So as you can see, the error is never happening. And if we're switching back to a blocking API, right? We're switching to the blocking API, it instantly happened, right? Because it tried to read it, and then it failed with probably E again or something like that. So let me take a look. Read, so errors. Where are the errors? Yeah, E again. The file descriptor of D refers to a file other than a socket and has been marked non-blocking, and the read would block. Okay, so I need to kind of know what E again equal to, so we're gonna yoink that thing as well. E again, right. Cool. So where is my main? Okay, so there's no E again, probably because I have to include something like error null. Right, and E again is 11. Cool. So here's the E again. So if 0, if read less than 0, we probably need to do something else. So I'm just thinking how I'm going to reorganize the code that takes into account E again, but if it's not E again, throw an error, something like that. Right, so I want to do the following thing, right? I want to do the following thing. Maybe I'm going to bind this entire thing to some sort of a return, and here we can have the following thing. If return turned out to be 1, we read 1 character, we're going to do the usual thing in here, right? So we're going to do the usual thing, right? We're going to process that input. So that's what we're doing in here. We're literally processing that input. Otherwise, if ret equal to E again, right? If it's equal to E again, we are going to... Maybe it has to be negative. I don't quite remember. I think it has to be negative. Right. How do you negate something? I forgot. I forgot how you negate things in port. Port. I think we don't have a negation in port. I'm pretty sure. Though we can always do something like 0 minus. Yeah, there we go. So that should work. Haha. So if it's E again, we just clean everything up and we're going for the next round. Otherwise, we're going to throw read failed, right? So that's going to be our approach. E puts read reading command has failed. E puts and then exit with this thing. There we go. So do we have everything closed? And we need to close the final return in here. There we go. So that's pretty cool because you can have several situations, right? If it's like 1, interestingly enough, like you want to kind of do that in both of these things. So like you want to do that in both of the branches. I think. I'm pretty sure that's what you want to do. So I think I'm overcomplicating this entire stuff, right? I'm pretty sure I could come up with simpler logic. All right, if a return is equal to 1, do that. Otherwise, if it's not equal to E again, we're gonna throw an error. I guess that makes sense. And then later it's easier to add more error handling here, though I'm not sure if we want to do that. Okay, so let me try to compile the snake, and we have some unhandled data. Oh, okay. Even though I'm pretty sure it is handled, isn't it? I'm pretty sure. Oh yeah, it's a 0. Okay, so we don't need 0 in like here anymore. Okay, cool. Okay, that's pretty cool. You can see some stuff. So the cursor going the cursor is going places, that's for sure. The cursor is going places, which is rather interesting, not gonna lie. So and by the way, that's kind of strange. So I presume this is because it's just going very, very fast, right? So and one of the things we want to do is probably slow it down a little bit. We want to slow it down. So we need to add a little bit of a sleep. I already implemented sleep before, so I have that in the game of life. So I'm gonna just steal that from the game of life. So goal porth, and this is literally how we do that. So we're gonna use clock, clock, nano sleep, right? And we also have like delta time, and delta time is set to, why is it set like this thing? I'm not quite sure. Oh, this is such an old code. Oh my god, this code is so old, I didn't have constants back then. So I had to allocate memory and set the value so I can use that. Oh my god, this is so cool. I really like that. So yeah, this is a very old code. So, that's very cool. I like that. Blast from the past. I even kind of remember like my process of thinking, okay, so I'm gonna do it like that, but later I'm gonna have constants, so it's fine. It's fine, but it's still there, so yeah. And since the code never broke, right, I had no reason to actually go back to this code and fix anything, right, because it works, right, so it's kind of cool, right, but now you don't have to do that. So, yes. Okay, and this is basically what we're gonna do in here. We go back, and maybe here we're gonna just wait a little bit, right? And here's here we can use a constant delta time, and where I'm gonna define that constant, I can define it somewhere here. So it's gonna be delta time, and that delta time is like, I don't know how much it is. So as far as I know, nanosecond, right? So nanosecond is, here's the microseconds, here's the milliseconds, so basically 100 milliseconds, right? That's what it is. 100 milliseconds, and that should be fine. So let me try to recompile the entire thing. Clock nanosecond pointer. Oh, wait. Oh, this is not true. Okay, so everything I said before is bullshit. Because I forgot. This is a pointer. Right. This is a pointer. So yeah, I see. So you have to pass a pointer to a structure. Okay, so everything I said is bullshit. I'm sorry. I'm taking everything back. So yeah, because clock nano sleep doesn't take a single number, it takes a structure. And what I do in here, I actually allocated, okay, that makes a lot of sense. The time, it's a size of time spec. Okay, so I'm starting to remember. Time spec. I have a case of false memory, I think. I think that's what I do. And this is a structure, and you can just set like seconds there or whatnot. All right, so delta time, that means we have to allocate the delta time somewhere. Though it's still an old code, because these days I would have allocated delta time as a local memory though, right? I wouldn't allocate it as the global one, right? Because there's no need to. Okay. Where is the delta? So this is a wrong place. Okay, so memory delta time, size of time spec end, and for the delta time, right, I can do something like delta time time spec TV sec, I think nanoseconds, right, and sec. Pointer plus. Though there is some benefit in allocating delta time in a global memory, is because it's going to be like zero initialized for you, but I don't know. So this is the integer, and for the seconds, right, for the seconds, we want to essentially initialize it to 0. So that's what we want to do. So it would be kind of cool to have like spilling and gathering from the stack for delta time. Just like for the point, so I could do something like delta, maybe like 0 delta time, and then say delta time, and then time spec, and it will basically gather these elements from the stack into this structure, which leads me to A very interesting idea is that maybe it has to be a feature of the language where you can define a structure, and this operation of like spilling the structure onto the stack and gathering structure from the stack, like generated automatically, or maybe it's somehow like a built-in operation, because I find it quite useful, because quite often this is what I want to do. This is what I want to have. I have a sequence of words which form a structure, and I want to like move it into the memory and out of the memory, and also access individual things from that structure. So you see, using this language, like just by using the language, I already getting the ideas for the designs and stuff like that. But I'm not sure about specifics yet, right? So it's all of that, you know, hand waving. Anyway. Okay, so clock now speed. Okay, so here we have to provide the pointer to this entire structure and everything's okay. Okay, so what if we slow down everything? How is it gonna look like? STTY and snake. Snake. Okay. All right, so it does not go all over the place at least, but it has a noticeable delay. That's what's interesting about this thing. 100 milliseconds is actually quite noticeable, because I can feel that like delay between me pressing a key and then this thing, you know, then appearing on the screen. Though in Snake game, usually like frame rate is rather slow, right? If you press something between sort of the ticks, it's not going to be processed immediately, right? It's going to be processed on the next tick, so maybe that's fine. You know what I mean? Maybe that's totally fine. Maybe that's exactly what we wanted here. So yeah, and I can just quit and everything's fine. So that's pretty cool. All right. I once tried to do Snake in C, but didn't know how to refresh it in regular intervals. You just doing that in C doesn't really give much information. What kind of output and input were you doing, right? Like the difficulty of doing that in C depends on what is the I/O. Are you doing that on a terminal, right? Are you doing that on a window? What window? Is that Xlib, or is that Win32 API, or is that macOS, whatever the fuck they're using? Is that OpenGL, right? If it's OpenGL, what library for the OpenGL? In terminal, okay, so, and in case of a terminal, it also depends what terminal. We're using some sort of a library, like ncurses, right? So there's like so many things, like just the language itself doesn't really explain like much about your project, right? So it like literally depends on how you get in the input from the user and how you displaying the output to the user, right? So you can make it super hard for yourself, or you can make it super easy for yourself. You want a 16 millisecond for 60 FPS. I don't think I want to have 60 FPS in here, to be fair. I think I'm gonna like relatively slow FPS. In fact, I might as well actually make it even slower. So maybe half of a second, maybe even a single second, who knows, right? Because I want it to be like processed like a real Snake case, like a original Snake case, Snake game. God damn it, Snake. All right. Half of a second is too much. We'll have to play with that. Yeah, we'll have to play with that. Okay. All right, so I'm gonna put 2 in here. So now we probably want to have the direction in which the snake is moving, right? So we have the player, and that's the position of the player. And now we want to have maybe a player pose, and then we're gonna have a player direction, player dir. And in case of a player direction, I'm not quite sure. Is it going to be another point? Or we can introduce enumeration of directions, right? So in that case, it's going to be size of an integer, right? In that way, we can have like left, right, up, and down. So let me actually see. So dir up is going to be 0. Down. What the fuck am I doing? I can just use offset. Offset. Left. And right. Okay, so and then we can have maybe count variable for all of the dirs. reset and end. And maybe I also want to define something like size of dir, which is size of integer. All right, and then I can embed all of that into sort of like a structure. Right, so player position, point, and direction. So that way I can actually have a more general function for moving the point in certain direction, right? So I can have something like, let me see, proc move point, right? Move point, it will accept the pointer and then it will accept an integer. The pointer is the point that you want to move and an integer is the direction, right? And it will move the point in that specific direction. Maybe I'm going to call it step point. What do you do in step point? Okay. So here, this is P. So this is P. And this one is the direction. So on top of that, I'm going to take P and spill it onto the stack. I'm spilling the P onto the stack. Disgusting. I'm to PL. What's up? Hello. All right. For Foidy, thank you so much for Twitch Prime subscription. Thank you. And welcome to our Epic Port Club. Really appreciate the subscription. Okay, so I'm spilling the P onto the stack, and here is X and Y, right? And depending on the direction, we're gonna modify that thing differently, right? So I have to do something like dir. If direction is up, I'm gonna do one thing. Otherwise, if direction is down, I'm gonna do another thing, right? Somewhere here we want to do something like unreachable, right, just in case, because that may happen. Then left and then right. Cool. Then left and then right, and then here it's going to be, if you want to go up, y is, it's a -1 for y, right? It's -1 for y. Down is +1. Left is x -1, and right is x +1. There we go. So that's basically how we're gonna do that. Right, so here you basically update this entire thing, and then you want to gather all of these things back into the point. Holy shit, this is so convenient. This is where LED bindings really fucking shine. Like, holy fuck. It just like makes it so much easier. Memory corruption case. Where is the memory corruption case? I didn't see it. Or what do you mean? So they found the P drawer. This is the most disgusting meme that I've seen. Oh, memory. Oh, you mean unreachable? Yeah. I see what you mean. Yeah. So this stuff may happen when you have corrupted memory, when you point in at corrupted memory, or maybe like here somewhere. Yeah. Do you think you would do pattern matching in Porth? Depends on what you mean by pattern matching, right? So pattern matching, what I think of pattern matching is essentially destructuring plus control flow, or control flow based on destructuring, right? So that means you can destructure things differently, and you can destructure things differently depending on their types, which means you need to store the types at runtime somehow, some sort of a tag, right? So you will have a structure and it has a tag for its type, and depending on its type you would be able to destructure it differently and stuff like that. So it's kind of like a lot of things at once. I'm not sure the Porth code base is ready for such advanced features. I don't think it is ready, but I'm thinking about a simple case of destructuring. Simple case of destructuring. Okay. And I don't think it's that particularly useful. Well, I mean, obviously storing somehow some types at runtime is rather useful, but I'm not sure if it has to be in that specific fashion. Anyways, so let me see. Is this entire thing compiling? So we don't have a player, and this doesn't have to be a player. So if I want to display something, This is the player position, right? This is the player position, player down. We don't need that stuff anymore, right? I can just do it like that. Unknown player, this is the player position, player down. Okay, that's cool. So essentially what I can do now is step point, player, direction down, step point, right. Then this is up, this is left, and this is right. Okay, so that's what we have. Maybe even at some point, well, yeah, you will be able to move player outside of that thing, but yeah, whatever. Okay, unknown player, because it's a player position, of course. It's a player position. Okay, not enough arguments for the point, which is... Oh, I see. Yeah, so essentially all of these branches push two numbers onto the stack, except this one. So in this one, we have to kind of like put a couple of dummy numbers just to type check this thing, right? Just to type check it. All right, because the type system doesn't really know that this is unreachable state, and you don't really have to type check it. But I mean, we'll see. We'll see how we can fix that. It's not really that important right now. It's not important. Okay, so if I try to do snake thingy, it seems to be working. Okay, it seems to be twerking. And what is the other thing I wanted to do? So now I have a direction. Okay, so that's pretty cool. And I can probably initialize the direction with something, right? So I can say direction left, right? And then I can say player direction integer. So that's the current direction. Interestingly enough, now instead of actually stepping the point when the player presses something, I'm going to assign the direction. I think that's what I'm going to do. So I'm going to remove all of these things, and this one is going to be player direction, and I'm going to just like assign this thing. Right. After that, what we're going to do, we are going to take the direction, step point, right, player position, and then player direction. We're going to read it, and we're going to say step point. Right, so we're basically storing the current direction, and we're stepping in that specific direction, and the player can change that direction if they want to. Right, so cool. Let me slow it down just in case, and I'm going to recompile the entire thing. So something is not working here properly, because I have to read integer, not write an integer. Thank you so much. The type checking saved the day. All right, so as you can see, it is moving, and I can quite easily change its direction by changing things around. So as you can see, I'm not moving, but I can then move it around. And considering that it's a snake game, I think it's still moving too fast. I think it is still moving too fast. So let me go to this case, and let's say that it's going to be 1 second. But if we're going into the territory of single second, I might as well just do the following thing. Right, so this is a nanoseconds, and the second is going to be 1. Right, if I want 1 second, I can just set 1 second in here. Who said I cannot do that? I can do that. So it's going to be literally a single second. Though I'm not quite sure why. We're moving to the... Yeah, I should actually move to the right, because that's what I would expect in here. That's what I would expect. Cool. Okay. Sometimes it's not like processing what I tell it to process, which is rather strange, but okay. We'll see how it goes. But yeah, so now we have a thing that just moves in a particular direction forever, essentially, right? We can also probably want the player to wrap around, right? We definitely want the player to wrap around. All right, so everything seems to be fine. Let's now wrap everything around. So we're going to be doing that in a step point. And essentially, how am I going to do that? I can mod it, but modding it is not going to work well because modding essentially produces like negative numbers and stuff like that. Though I can just do a very simple case of, you know, duping the entire thing. So maybe I'm not gonna do mod. So this is X, right? So this is the new X. And I'm thinking, can I just like bind it again? This creates like sort of like immutable programming where, okay, here is the input X and here's how I describe its modification. And then I bind it again, but X and Y now are different, right? They're modified like within this block. So this block sort of accepts inputs and provides the outputs, and you can have like several blocks that chain together modifications, which makes, I think, cryptography a little bit easier, because like cryptographic algorithms, they use these diagrams. I forgot how these diagrams are called, where you just have the states of the variables and then like they're shuffling around and then operations and then another phase and another phase. How these diagrams are called? They have like a very specific name. Do you guys remember? Like, I forgot the name of these like diagrams. They have like, they're named after somebody. And I can never remember names. Okay, chat also doesn't remember. All right, so, and yeah, it kind of reminds me of that. So, and in here we can do something like if essentially X, maybe X is less than 0, right? If it's less than 0, that means X has to be equal to 0, right? So X equal to 0. Otherwise, if X is rows X greater or equal than, that means this has to be rows -1. Otherwise, it's going to be just X, and we're going to just end this entire thing. Can I just like, yeah, I think this is what I can do. If that's, this is going to be 0. Otherwise, though I can do something like, okay, X 0 maximum, all right, and then rows -1 minimum. So, and I sort of like clamp this thing, right? And the problem here is that I don't have a minimum as an intrinsic, right? But do I need minimum as an intrinsic at all? I needed maximum as an intrinsic because I needed to use it in a constant evaluation context. So I think I'm going to introduce that a little bit later. All right, so, and for this specific case, I'm gonna just like do it. By the way, rows has to be columns, right? So this is columns and this is rows. Just for now, right? So we're just clamping it around. Hopefully that will work. Wait, no. I'm not trying to clamp it though, am I? I'm trying to wrap it around. God damn it. I think I need to make a break because my brain is all over the place, so I need to kind of like gather my thoughts. So let's make a small break and All right, so the main challenge here is that the mod and div in Porth, they are unsigned, right? So we don't really have a signed version of div and mod, which is something that we probably need to fix right now. So let's go ahead and modify the compiler so it supports like signed div and mod. For div and mod, we have a special instruction intrinsic called Diff Mode, which performs div and mod simultaneously. It takes two numbers and then it returns two numbers, the first of which is the result of the division and the second of which is the remainder of the division. So, and this entire intrinsic uses the div instruction under the hood, as you can see. So it uses diff, which is unsigned. But for us, we need to have a signed one to properly do the modular. So let's go ahead and literally introduce a new instruction, a new intrinsic called idiff. Right, and it's going to be literally as diff mode, but it's going to be signed. So let's try to recompile the compiler. So modifying the compiler right in the middle of implementing the game, so I can implement the game. So that's pretty cool. 45, so 46. This one is going to be idiff, and this one is going to be idiff. So usually you don't use diff mode directly. It's wrapped around a couple of like helper functions. So if you take a look at this thing, so there is, let's find div mode. Div mode, yeah. So this is the functions that you usually would use, like slash or percent or mod or diff, and all of them they just use diff mode like under the hood. So for idiff mode, it's going to be the same case, right? It's sort of like a low level intrinsic, and on top of that low level intrinsic, we're going to have like this stuff like this. ARM has idiff and udiff, x86 also. Yeah, but in x86, udiff is basically just diff. Right. I believe this is because like signed and unsigned integers are multiplied and divided differently. Right, in case of the addition and subtraction, you can use the same instructions for signed and unsigned ones because of the 2's complement, right? So 2's complement actually makes it super easy. But in case of multiplication and division, you can't do that, so you have to have separate instructions for those. So in the future, actually, what I'm thinking is that we're gonna dispatch like diff mode or idiff mode depending on the type. So we're probably gonna have like int and uint, and depending on the current type on the stack, we're gonna like dynamically like overload and dispatch to two different like instructions. So that's gonna be in the future. But right now we have to be very explicit about that. All right. So let me see. So that's another one. Diff mode. So idiff mode, 45. Now we have 46 intrinsics. And I believe after I get accustomed to let bindings, I'm gonna remove a lot of like stack manipulation intrinsics. We'll see. I definitely want to remove rot because rot is kind of like difficult to use. And I don't find it particularly useful. Swap, drop, and over and dupe, they're kind of actually useful, but rot is just like, it's too complicated for me. I don't know, for my brain. We'll see how it goes. Okay, so here is the generation. Let's find diff mode, and this is literally what we're gonna do in here. I'm just gonna like copy paste this thing. This is idiff, and this is idiff. And that should be basically the implementation. We'll see. And so here's another one. What do we have in here? We have a type check-in, which is fine. So the diff mode is going to be type checked exactly as idiff mode is going to be type checked exactly as diff mode, right? So nothing new in terms of type check-in, and there we go. We should have a new version of the compiler. So compilation takes 1 second for whatever reason, probably because I'm streaming. But yeah, it fluctuates a lot. So, oh yeah, we have a new version of the compiler. Binary rotation or stack rotation? This is a stack rotation, yes. So it takes 3 elements on the stack and rotates them. And usually, instead of rotating, like what you want to rotate usually when you want to access the 3rd element, right? So that's what you usually want to do. So you have 3 elements on the stack, and you want to rotate to access this element, right? So just to do that. But quite often you don't really want to like, you know, remove it from that place. Quite often you want to pick into that element. So you want to have something like over, but the one that looks over the B, right? So that will do something like this. But what if we have even like 4 elements in here, right? So what if we have like D or something like that? The like 4th fan would tell you that if you have to think in terms of these many elements, you're probably doing something wrong. You're like not believing enough into the values of 4th or something like that. In 4th, you can just do something like this, right? And there you go. You access D. So if you want to access D in 4th, this is literally how you can do that. You can just like bind them. But that kind of like removes all of the elements from the stack. And again, I'm thinking to introduce actually pick construction that doesn't really remove these elements from the stack. It only like picks into the like this one and lets you push it on top of the stack. So yeah, I'm not saying that the way 4th does that is wrong. It's just like I personally don't enjoy programming in that style. And there's probably place for 4th style of programming, right? Like very, very low level. I think 4th is slightly higher level than 4th. Is 4th compilation written in 4th? Yes. Yes, it is. Then we're generating porth.asm, and then we're generating the actual executable and we're replacing it. So every time I recompile porth, the porth executable replaces itself with the new version. So that's what's going on here. You really don't need that much of keeping the stack in your head anymore. Exactly, right? That's the main challenge of using stack-based languages, that you have to keep too much information in your head. But if you have some constructions that can help you, it becomes a little bit easier. But this feature, the let bindings, is like a little bit rough around the edges. So, and that's precisely why I'm making this game, to just like reveal all of the roughness of this thing. Anyway, so let me try to experiment with the idiff. Right, so this is going to be my new main, and in here I want to do something like 101, and I want to divide it by 100, and then I'm going to do idiff mode, and then so the first one has to be result of the division, right, and then the remainder. So, and let's go ahead and just print them, dprint and rprint. So that's what we're doing here. Okay, so let me now run the snake. So, and that's the result. Okay, fair enough. The result of the division of 101 by 100 is 1, and the remainder is 1. So we have something like 5. It seems to be working, right? So 1 and 5. Cool. So now what I want to do, I want to actually use -1, but that won't work because we don't have negative numbers. We can do something like 0, -1, which will produce the negative number, but print is incapable of printing negative numbers, so we're going to get a huge number. Right, so here's the huge number, and this is what we've got, right? Which kind of confirms that it is like kind of like a negative number. We can like try to convert it to int. I wonder if you can just do that. Can you in Python or Python 3? All right, can you just do something like that? I didn't think you can easily do that. Whatever. Anyway, so it is a negative number. And if I try to use diff mode, it is a negative number, but slightly different. All right, I'm not sure if that's what I expected in here, though. Oh, wait a second. So if I use idiff, what's the difference between them? So this is sus, I think. This is sus. Because the result of the division has to be different. So where do we have all of that stuff? Where do we have all of this stuff? This is truly, truly sus. So it has, the result of the division has to be 0, and the mode has to be like -1 or something like that. So if I, in something like node, right, I think nodes has the same behavior, and I do -1 divided by 100. Okay, so let's not do node. Thank you so much. Thank you so much, JavaScript, very cool. So let's do it like this. -1 divided by 100, and then I'm gonna do mod. I just want to see those things. Main.c, and also let's run the entire thing. Okay, that's what I would expect. The result of the division is 0. The remainder is -1. That's what I want to see. For some reason, I don't see that in Porth. For whatever reason, it's like doesn't make much sense. All right, so this is a diff mode, and in case of diff mode, so the result of the division -1, and this one is 15. And even if I switch to diff mode, it's still that one, which again, super sus. Super sus. So in case of this thing, it seems to be correct. The result of the division is 0 and remainder is 1, and it doesn't matter if that's... Yeah, so that seems to be fine. But once I switch to -1, right, so that's basically -1 divided by 100, that's where it gets incorrect. And it doesn't even change, right? It doesn't even change if I switch to between diff and idiff. And it is very interesting because, okay, let me try to isolate this entire example, right? I want to isolate this entire example and I want to see what's going on. So this is going to be foo, and I'm compiling foo, right? I'm compiling foo, and then I'm going to take a look at the assembly of foo, right? Okay, so what do we have in here? Where is the diff instruction? So here is idiff. All right, so maybe I'm doing something wrong. Maybe I'm not necessarily understanding what diff and idiff do. So you probably need to sign extend rex into RDX. You can use CQO for that. That could be actually the case. Diff. God damn it, it's also 128. Yeah, I keep forgetting about that. All right, thank you so much. Yeah, it's one of those instructions. It's one of those. Yikes. Yeah. So you probably need to sign extend rex into RDX. Okay, so let me try to maybe read about idiff. x8664, and let me see CQ. Is that an instruction? Not sure. Convert word to double word. Okay, so signed divide. Divide the signed value ax, dx, edx by the source operand divisor. Okay. And store the result in ax, dx, or edx registers. The source operand can be... So where does it store remainder then? Does it store remainder anywhere? Okay, so let's do x86, 64. So let's actually take a look at the diff. So diff does store remainder, and that one doesn't. Okay. Diff x86 64 remainder. So there is a cheat sheet. Remainder. But that's exactly RDX is a remainder. And I set RDX to 0, by the way. I set it to 0, I'm pretty sure. But I'm not I'm not sure if it's about sign extending. Why would I need to sign extend it? I would expect it to be not sure. This is really sus. It really doesn't make any sense to me. It really doesn't make any sense. Anything, Joe's, thank you so much for 5 tier 1 subs, for gifting 5 tier 1 subs. Thank you. It really doesn't make sense. I'd love to step through the debugger. I think that's one of the things I'll have to do, just to understand what's going on. So I do that, I pop RBX, pop Rex, and I just divide it by RBX, and then push Rex, and then push RDX. So I'm not sure. If you're using signed, RDX shouldn't be 0. It should be extended from Rex. It's weird, but it's did this earlier. It doesn't make any sense to me, I'm sorry. Okay, so I think there I should look for examples. I diff assembly example. Okay. Remainder AH. Okay, so in case of like this this instruction that operates on like small things, a remainder is in here, right? Remainder is in here. So it's 32-bit, so I need to specifically look for 64. Yeah, and they actually, yeah. 64 Go DevTools. Demonstration. There's not that much of examples, which is kind of annoying, right? Specifically for 64. Why are you throwing videos at me? Examples. A div queue with 2 operands. Okay. It's so annoying. I have an idea, actually. I have an epic idea, so fuck all of that. So we're gonna just literally go and put that into the Godbolt. I think that's the easiest way to go about that. That's the easiest way to go about that. So let's just see. Okay, show me the result. It's gonna take some time. Probably I don't want to you know, do any of these things. I didn't see any idifs. Where is idif? Zor, move, call, Zor. Did you try to optimize that thing? Could you please not optimize it? I would really appreciate that. Okay, so probably wanna do something like this. So we're gonna accept X and Y, and maybe I wanna even make them long. Oh my god, this is so slow. It's unusable. Okay. So long int f, long int x, long int y, and then, right, we're gonna simply return x mod y, right? So I just want to see how you're gonna approach this thing, right? I'm gonna use Godbolt. Okay, show me. idif, and it just like, yeah. So you just move, it just uses RDX directly. That's what it does. It uses RDX directly and just returns that. Okay, so maybe if I now use like a different thing in here, right, something like this, and long int, and can I call this function -1 and just return it? So I want to have some layer, like I just like don't like that Clang tries to optimize too many things. So all right, so RDI. I didn't see anything special, believe it or not. Like there's nothing special. That's literally how I do that, I think. Oh, and the cool thing I know now is that you can actually divide by memory, which is cool, right? So I just move that into a Rex, I divide it by that specific memory, and then I use RDX as the remainder. So, and that's literally how I do that, without any signed extension or whatever that's supposed to mean. I don't know what that means. Right, so it's just like, yeah, that's even Godbolt tells you that that's how you have to do that. So the problem might be somewhere else, I think. I think the problem might be somewhere else. And the question is, where is the problem? Where is the problem? So, and I don't like that I don't go anywhere. Like, I don't like that I'm stuck on this thing for too long. So this is very, very annoying. So let me try to maybe it's something with the LED bindings, right? Okay, so because LED bindings are kind of like a new thing, let's make it a little bit simpler. Let's make it a little bit simpler, right? So let me try to run that. Okay, so, and it's still 15, so what if I don't do this thing? All right. So that makes maybe a little bit more sense, so does it? So it's going to be 100 and then the negative number. So something is really weird. Is the order wrong in here? Not really. No, it's fine. So first I'm extracting RBX and then Rex. Right, so and that's precisely what I want actually. Yeah, that's precisely what I want. Yeah. It needs CQO. I don't understand what you guys talking about. Why there's no CQO in... Oh, here is the CQO. God fucking damn it. I literally didn't see that. Okay, so I literally missed it. I specifically got into Godbolt because I wanted to see it. And it's so difficult to see it, actually. Holy shit. Oh my god. Okay, so... what is CQO, though? That's why I didn't listen to the chat, because I just like got into the Godbolt. So of course people need to be toxic about it. Okay, so let me read about CQO. Doubles the size of the operand in the registers depending on the operand size. Okay, so we can like stack it in there. Okay, so I need to recompile the compiler, of course. CQO before NDiff? Oh yeah. Okay, so I probably need to read that. Oh, I see what it does. Oh, I fucking now understand. Okay. All right, this is actually very funny. I see what it does. I see what it does. That's kind of cool. Okay, and it makes sense. Right. So in 2's complement, if the number is negative, right? It has these trailing ones, right? So it has this trailing ones. Essentially, I can even try to do something like that. So if we have something like 4, 1, 0, 1, 1, and if you want to turn it into a negative one, you invert all of the bits, right? So 0 goes into something like this, 1 into 0, and then query into 1, right? And then you add 1. So in 2's complement, negative numbers have these trailing ones, and because of that, this bit here is indicates the negativeness, right? So when you start extending the numbers 1, 2, 3, 4, 1, 2, 3, 4, negative numbers, because of the 2's complement, may turn into positive ones. So because of that, in the CPUs, there is like a special separate operations for extending. Right. So, for instance, if you're reading 8 bytes into the 64-bit register, you have to read it as like with extended sign to like extend this trailing, trailing ones. So, since diff and mols are 64 bits, that means their span across 2 registers. So the lower bits are in rex, the higher bits in RDX. That's very interesting. So if you reset RDX to 0, that means whatever negative number you have in rex, right, whatever negative number you have in rex is going to be positive because you have trailing zeros in RDX. So you have to extend rex into RDX. So now it makes sense. This is actually super cool. MM2PL got it. Yeah, that's okay. That even makes sense. Yes, yes. All right, that's cool. So Chaos Driver, thank you so much for 4 months of Twitch Prime. Thank you, thank you, thank you. Extend your Rex into my God damn it. All right, hello G, what's up? Okay. Now, at least we learned something today, so that makes sense. I wonder if you... Can you do that kind of manually? Does it overwrite RDX? Does the RDX have to be set to 0? That's what's interesting about that. I didn't think it has to be, right? Because as you can see, we don't even mess with RDX. We literally do nothing with RDX. We just like, yeah. So I suppose CQO just overwrites whatever you had in RDX. That makes sense. Okay. So maybe we don't even have to do this thing. So we just pop RBX, Rex, then we extend Rex into RDX, and then we do diff and everything's fine. All right. So let me recompile the whole thing a couple of times, just in case, you know. And now I'm gonna try to run this entire thing. And now this, does it make a little bit more sense? It doesn't, but we're pretty close. So I'm gonna do idiff. And now it makes a lot of sense. There we go. So yeah, I'm dividing -1 by 100. I expect it to be 0. Let's actually do something like A and B in... So A, B, all right. So that's cool. So the result of the division is 0 and the remainder is -1. Perfect. That's pretty cool. Okay, so let's go back to the snake. And this is where I want to introduce a new mod operation. Euclidean mode, right? So we need to have some sort of Euclidean mode. Let me try. So I'm gonna call it emode. It's gonna accept 2 integers and return a new integer. And it's going to take into account the negative numbers as well. All right, so A and B, of course. Now, you know what? I want to have something like imod. So I'm gonna do A and B, imod. If A is negative, the final result is going to be negative, which means that I want to add B, right? But now we have a situation when the positive case is broken, right? The positive case is broken, so we want to do this thing yet again. Right, and let's actually introduce something like imode, integer, 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 and in here we just do idiff mode, and we want to swap and drop it, right? So we're dropping the result of the division, leaving only the mod. Okay, so that's cool. So this is what we have. We have imod, and then in terms of imod we have Euclidean mode, right? Which basically, if you have a negative number, it just wraps around. So that's how we can do that. And let bindings actually shine here yet again. It just like makes it super easy to like reason about. Okay, and now the result of the Euclidean division or Euclidean mode in here has to be 99, right? So it has to be 99. All right, so I'm gonna just do print. Let's do snake. There we go. Epic. So now we can basically use this E mode to wrap around negative and positive. So that's pretty cool. All right, so and this stuff can be actually put into the standard library as well. std port, so where we have diff mode. Diff mode, here it is. Right, and we might as well also introduce... Oh, by the way, let bindings are inlineable, so that means I can do shit like that. Cool. All that is inlineable, and I can even have maybe idiff. Alright, so idiff, which is just div mode but drop. Right. Yeah, there we go. Okay, that's pretty cool. So of course this is not the final design of the language. Like in the future it's going to be a little bit easier to do this kind of stuff, right? And in fact, like the fact that I'm working on things that make it difficult is already a good thing, right? That means it will force me to fix these things in the future. All right, so snake port. Now, what I want to do, so when I move around in here, so instead of doing this kind of stuff, which doesn't work right now at all, by the way, I'm going to do x calls e mode, and then y, actually this has to be, yeah, this has to be calls, and this has to be rows, and that's it. So that should be it, in fact. I didn't mean to do that. So, all right. Okay. So let me actually speed it up a little bit. Delta time. Where's my delta time? Am I in the right place? I didn't think so. Oh yeah, it's 1 second. Okay, so let me 1 to 3, 1 to 3, something like that. I don't want to do that. I just want to recompile the entire thing. Okay, so I'm gonna go down, and as you can see, it wraps around. Cool. We had to modify compiler, and we had to learn about weirdness of x86-64, though signed extend into RDX does make sense, right? It does make sense. What doesn't make sense is that why do you need to have 128-bit division, right? Who uses that? How often is it used? It's a really interesting question. All right, cool. So another thing I want to be able to do, like this doesn't look like a snake at all, right? So anyone would agree. It doesn't have any tail. So I think the time has come to introduce the actual, like, how will I say that? The actual board of the game, right? The actual board of the game. Let me see how we can do that. So we have different directions, we have a point. So I think I'm going to introduce the cell, right? So this is going to be const cell, and we're going to have different kinds of cell. We're going to have an empty cell, offset, and then we're going to have the cell that stores the body of the snake, right? So maybe it's going to be like cell snake. It's a cell that is occupied by the snake. And we're going to have cells that contains egg. Right, so we have empty snake, egg. Yeah. Maybe if we wrote it, it sounds a little bit better. Empty egg snake. Okay. Anyway. So, and here we're gonna have count cells, right? And it's gonna be reset, and it's gonna be end. And also we want to have size of cell, and it's just basically an integer, right? Now I want to have a memory that is occupied by the cells, right? So this is going to be memory and cells. Size of cell multiplied by rows multiplied by columns. Multiplied by rows multiplied by columns. So we occupied enough memory for the cells. That's pretty cool. So, and when I'm displaying the cells, right, so when I'm displaying the cells, what I want to do, in fact, I want to just display whatever we have in there. Also, the notion of the player position doesn't make much sense to me anymore, I think. Well, it does make sense. Yes, it does make sense. Because it's the position of the player's head. That's what it is. It's the position of the player's head. We also need to keep track of all of the positions of the snake itself. So in fact, I think we need to organize some sort of like ring buffer, right? We're going to have a ring buffer into which you can push new things and then pop out at the other end, right? So, and that way you'll be able to have some sort of a trail. Okay, so we need to organize the tail thingy, I suppose. Right. So, and tail has to have a certain capacity, right? So let me see. Tail. Maybe we're gonna call it snake capacity. So how long can the snake be? I suppose as long as the size of the entire board, right? So the snake capacity is essentially rows multiplied by columns, right? That's the snake capacity. So the snake itself will consist of the points, right? So it's gonna be memory, snake, size of point, snake capacity, right? So this is the snake. Since it's some sort of like a ring buffer, we maintain two things: the beginning of the buffer and the size of the buffer. So working on a mod was actually very useful because we'll need a mod in here, though we don't really need signed mod. We can use unsigned one, so that's fine. Okay, so we're gonna have a memory snake begin. This is where it begins in an array of points, right? Size of integer, right? And snake size, it's how many like elements is in the snake. So all of that is 0 right now, but it doesn't really matter. Okay, so what we want to do, we want to have a couple of operations in here. The thing that adds to the snake, right? So at the top of the snake, right? So at the beginning of the snake. So add. And what we're going to add in there, we're going to probably add a point. But the question is how we want to add the point. So we're going to accept a couple of integers, right? So in, and this thing is not implemented yet. So snake add is not implemented yet. So this is not implemented yet. And then snake del, which basically removes from the end. And this is not implemented yet as well. Snake del is not implemented yet. Okay, so that's pretty cool. And I'm thinking, when I add something to the snake, should I also update the cells? Probably. That's probably what I have to do. All right, so let me see what we can do in here. So this is where this entire thing starts. So I want to do 5 5 snake add. Then so since it's x, right, I have to do 6 7 8, right? So that's what we have, and the player position is somewhere here. So that's basically the snake. So it's more of a player. Yeah, let's keep it like that. So we added a bunch of things. That's cool. Now I need to change how I render the entire thing, right? So we don't really care about the player position anymore. It doesn't really matter. So the only thing we care about is X and Y, right? So here's X and Y. And then within the X and Y, we want to access the current cell, right? So we do Y. All right, so we do Y multiplied by the columns, right? So we multiply it by the columns, and then we add X. That gives us the index, right? That gives us the index. Do I want to do it as an index? Maybe not. Which I want to multiply by the size of the cell, right? I'm multiplying by the size of the cell, and I'm adding it to the cells. I'm offsetting it by the cells. And there we go, I got a pointer to the current cell, which I can try to read as an integer. And then, yeah, so I can just do something like cell. So if the cell turned out to be cell empty, right? So it's an empty cell. Though, you know what, I can like use maybe strings, if you know what I mean. Right. I can put something like this. All right, so it's gonna be the empty cell is a dot, the egg is asterisk, and the snake is gonna be that, and this is gonna be a C string, right? And then I can just use that as an index within that stuff. So that means I can just plus this entire thing. So I have set it, and then I read as a character, and I can just print that character. Holy shit, that's a lot. That's a lot of shit in here. But that's what's cool about this language. Is that you can go crazy like that if you want to. And I'm not even sure if it's gonna work first try. Rolf, thank you so much for 20 months of tier 1 subscription. Thank you, and welcome to our epic Port Club. How about that? So that's cool. That's cool, no? So what is the difference between C string and a string? A regular string is actually two things. It's size of the string and the data, right? So it's size string, and C string is multi-unity string, right? And I want to support both because I personally prefer sized strings. I really like them. I think they fit like in more cases than C strings, but unfortunately the environment we're working with is written in C, and the C code expects C strings. So you need to support both if you like size strings. So that's the main difference. So, and in here, right, interestingly is that I could have just used regular strings, but that means this thing will also push a size of the string on the stack, and I don't really care about the size of the string. So I think the easiest way to put here is just like C string. It will be null terminated, but that's fine. Read int is at int. Yes, read from memory. Oh yeah, it's true. Yeah, thank you so much. But I mean, the type system would have told me, because int and this thing, they have different signature and they accept different arguments, so it wouldn't compile, right? So that's fine. Okay, so here I'm essentially figuring out the index, right? So this is the index within the cell. This is the offset within the cell's array. And then I read in the cell, and that is number, and which is an offset within this array, which I add in here, which probably means I have to do plus pointer. And then I'm reading a single byte, and I'm printing that byte into the standard output. So that's basically what's going on, which is nice, right? So that's pretty cool. It's a bit complicated, but you can make it a little bit more readable if you use more lets in here. I think you can do that. I'm pretty sure you can do that. Okay, let me try to recompile the entire thing, and the result is a single number. Okay, so I forgot to multiply this entire thing. Thank you so much for telling me. Okay, so here I have unhandled data, which I need to drop, which is, yeah, fine. Pointer plus, maybe this is what I have to do. Yeah, there we go. That's what I'm talking about. That's what it's all about. That's what I'm talking about. Alrighty. Okay, if I try to run this entire thing, it will tell me that snake 8 is not implemented. So if I try to do something like that, as you can see, this thing is not implemented yet. Right. So, and how are we gonna go about that? So this is X and Y, right? The first thing I probably wanna do, I wanna set the current cell to that. So I already want to copy paste this pattern, which means that I probably want to wrap it into something. Right, so this is X and Y. So here's that. And what I want to do, I want to set cell snake at here. Yeah, so I'm saving cell snake at that specific place. And now I want to add the int into the queue at the beginning, right? I want to add it to the queue. So, all right. First thing we probably want to do, we want to see if size does not overflow the capacity. So that's literally the first thing we have to do. Snake size integer and then snake capacity. This entire thing should be less, right? And if it's greater or equal, we need to throw some sort of an assertion, right? Assertion failed. Snake overflow. So the snake has overflowed in here, right? But we set the capacity to the size of the board, which means that by the time it happened, well, you basically won, I guess, right? And maybe we can even check for that. I don't know. So, but it's nice to check that nonetheless, right? Especially in such an unsafe language as Porth. So now, or just you, you won. Yeah. I like it. It's actually pretty good. Yeah, thank you so much. Yeah, you won. So it's a valid case. It's definitely a valid case. Anyways, next thing, we need to take snake begin, right? So this is an integer, and I want to add snake end, a snake size, right? So this is a snake size, and this is where we want to put the thing, right? So I'm adding these things together, I suppose, and I need to wrap it around the capacity just in case, right? And like we don't really need signed mod in here, so I can just use a regular mod, right? Snake capacity mod, right? And that wraps it around. After that, I want to multiply it by the size of the point, right? So because this is a bunch of points, right? I'm multiplying like that. And now I just want to read the like x and y into that, right? So that means I want to do x, y, and I'm just gathering all of that into here. Putin. Voldemir. Voldemir. Anyway, all right. So x and y, we're just figuring out this entire thing, and we're just saving this entire stuff in there. Cool. Now, when I'm deleting something, I want to do a similar thing, but I just want to put the empty thing. All right. Okay. So this is going to be empty, and in here, what I need to do, oh, I need to also increase the size. That's quite important. So after that, I need to do snake size inc 64. There we go. Snake size x64. Do you need anything else? I don't think so. Okay, so I set empty in here, and then I just need to increment the begin, right? I'm just yeah, that's fine. Snake begin increment 64, and I need to also wrap it around just in case. Snake size is going to be decremented, right? So decremented. Snake begin is going to be incremented, but it also has to be wrapped around, so I have to do that slightly differently. So I'm going to read it 1 plus, right? So I read it 1 plus snake capacity mod, and then snake begin, write it back. All right, so that's what I have to do. And also I want to put some sort of a assertion in here, right? That snake size is greater than 0, right? If it's less or equal than 0, right? So this thing is if it's greater than that, if it's less than 0, and it means assertion failed, snake underflow, right? Yeah, but it's quite unlikely you reach that unless we will introduce mechanics that reduces the snake, which is quite unlikely. So this is size, this is that, and I guess that is it. Right, so now this basically creates the ring buffer, right? So that's what it does. So point, so it means I need to move everything related to the point a little bit higher. All right, so where do I have a point definition? So here's the point, and yeah, let's actually keep it in here. So point. So it expects the pointer. I think I forgot something in here. So this is the capacity, then I multiply it by that, and that means here I have to do snake plus pointer. So, and that's not enough arguments for less, and that makes sense. So data stack does not have enough element expected. Ooh, that's cool. Oh yeah, okay, so I'm an idiot, right? So when you delete, yeah, you have to do it like that. Okay, so I think I can do that. So essentially I take a snake begin, I read it, and that's the offset, essentially. That's the offset, size of point, multiplied by that, and then snake plus pointer, and just to read whatever you have at the beginning, right? So whatever you have at the beginning, it's x and y. In that case, you set it to empty, then you decrement the size, and you increment the begin. I guess that's what we're gonna be doing here. Okay, wait, that's cool. I think it worked, right? But it's staying in here because we didn't implement the actual, you know, the actual thing, the actual like modification of the snake. Okay, so player step. So to step the player, right? To step the player, one thing we have to do snake delete. We have to delete one thing from the tail of the snake, right? We're deleting it and stuff like that. Then we take the player position and we increment it by 1, and we have to take that position, right? Player position, read it as a pointer, and snake add. Right, so, and that should be it, essentially. All right, so let me try to do it like that, and let's try to run the snake. Easy peasy, lemon fucking squeezy. How about that? Though it's quite funny that it can actually go in opposite direction. Yeah. But in any case, we did it. Poggers in the chat? Where are the poggers? I didn't see any poggers in the chat. That's cool, isn't it? So I could show you one more time. So we're having actual snake written in Porth. That's very cool, actually. Holy fuck! And I did that within. It took me 2.5 hours. What the fuck? And I never. By the way, here's the interesting thing. I never wrote snake in my entire life. I think. I'm pretty sure. I would have remembered that. But I never wrote it. Like, I kind of theorized and like never had an opportunity to do so. This is also literally my first time implementing a snake. I implemented a lot of small games in past, like tic-tac-toe and whatnot, but never a snake, which is rather interesting. Right. Okay. We can make the snake a little bit longer, right? You can always just like add more points in here. So this is going to be 9. 10. And we can probably automate that, right? So we can just have, you know, const that indicates the size of the thing, initial size, and it just like pushes and then saves the last bit into that thing. All right. So let me see. So it's a bit longer now, right? It's a bit longer. That's poggers. Drake Soren, thank you so much for 12 months of tier 1 subscription. Thank you. Really appreciate that. Cool. So there's so much that we need to implement in here. All right. So the next thing is probably disallow moving in opposite directions. It shouldn't be allowed, I think. But we need to know how to check for that. So at s. Well, we can do something like this: cmd_s and player dir. We just read it. Player direction. We can always do something like this. All right. Dir. If it's down, up. Land. So yeah, we can do it like that. If it's up, not down, right? If it's left, not right. It's a very dumb idea, actually, right? So this doesn't have to be equals, of course. So if it's right, not left. Oh yeah, I see where I did a fucky wacky and oopsie doopsie. Yeah, okay. Okay, so now I cannot go in opposite directions, which is cool. So I cannot go through myself. That's epic. That's actually very epic. Huh. Okay. So I'm thinking that I want to have some code that sort of initializes the size, right? So, but I'm not sure. I'm kind of a little bit tired as well already, so. And also here is an interesting question. So if we made it long enough, right? If we make it long enough, let me try. So can I go through myself? Yeah, I can go through myself right now, which is kind of funny. Like it creates a very funny results. It's like it allows you to cut yourself. Right, so it's gonna be 13, 13, 14, 14. Yeah, it allows you to like leave holes in yourself, which is funny. And yeah. So we can quite easily detect that you like collided with yourself. I think we can easily do that. So suppose, you know what? I want to have cell at, if you know what I mean. Inline procedure, cell at, and it accepts 2 integers, right, and returns you an integer. So, and we can already grab some of these things in here, right? Cell at. So this is cell at. Might as well actually take it as a pointer. Do I want to take it as a pointer? Because sometimes you want to save something there. So yeah, let's actually return a pointer. That's a good idea. All right, and then you could read it or not read it. So here's the player position. All right, so this is the new player position with step point. Then I'm gonna take player position, spill it onto the stack, and take a cell at that specific position, and I'm gonna read it. And if that cell is equal to cell snake, all right, that's it. You lost, right? You essentially lost, and I'm gonna say something. You lost Zulu. Puts, and I'm just gonna exit with a non-zero exit code. But maybe we just exit with 0, 1. Right. Let's see. Though. It's gonna be strange because the terminal is in a really weird state, right? So it's gonna look kind of weird, if you know what I mean, right? It's gonna kind of look weird, but we'll see. So let me try that, and okay, so I'm gonna just try to go through myself, and you lost Zulu. So I probably also forgot the new line. So yeah, so we can detect that situation. Oh, that's kind of strange. All right, so that detected that. Sometimes it doesn't properly detect that, and I'm really, yeah, so that detects that. Yeah, okay, that's cool. It does in fact detect that. So, and we can also now like randomly spawn a fruit, right? So we can randomly spawn a fruit. So let's have something like proc spawn fruit. Actually, is it called fruit? We call them eggs. Let's call them eggs. And in here, we'll just have to generate random random positions and check if they're, you know, empty or not, and just spawn an egg in there. So but we have to do that after we generated a snake, right? So let's do something like 0 while dupe, and let's maybe generate one of them right now. So it's going to be one at a time. Spawn egg, and that's it. Cool. So how are we going to do that? So we have a random number generator in the standard library, rand. So rand state, and we have a srand, and I also have rand. Okay, cool. So I'm gonna do that, but interestingly enough, I think I want to throw away first lower bytes of this thing, because they're usually not very much random. So I'll have to do 32 and shift left, right? So I'm throwing away that stuff, and then I want to take calls and do mod on them, and I want to repeat that for rows as well, right? And that should give me random 2 coordinates, and I want to kind of do that while those coordinates actually not empty, right? So this is x and y, and I'm gonna do over cell at. I'm taking cell at, I'm reading that cell, and we're gonna do that while cell is not empty. We're gonna keep repeating that literally until we get something. Once we've got something, we want to put egg in there. So it's gonna be cell at int, right, and cell egg, like so. All right, so that was actually pretty easy. So yeah, you just keep generating this entire thing. Yeah? I really like how straightforward that is. Pretty straightforward. Okay, so that's that, and we also, yeah, I suppose you have to drop that. Oh, that's cool. Wait a second. I wonder if it's gonna work though. I think it's gonna work, right? Because we're kind of consuming. Well, yeah, you kind of have to drop them in here. Yeah, I see. Okay, so n. Well, that's interesting. Okay, why is that an n? Why on earth that would be n? Egg display offset. What did I set there, by the way? I set an egg in there, which makes sense to me, but maybe it is not. Okay. Is it from new line? New line where? Proc display. No. Okay, so we'll have to rethink this entire stuff. I think I need to be a little bit more careful in here. So let's go ahead and just do maybe X and Y. And then do cell at, and I'm gonna read this entire thing, and here is the cell. Right. And if cell is cell empty, right, I'm going to return this thing. Otherwise, if cell is cell egg, I'm going to return this thing, of course, else cell snake. I'm going to return this thing, else unreachable. Here he puts assertion failed, unreachable, one exit. So, and in here I should be just able to do pooch, right? So this is y and x. I read a cell at that specific place. I read a cell at that specific place. If the cell is empty, I do that, then that. And in here I probably have to put something like 0. Might as well just do a putch on all of them, because why not? And then I return everything back. So that's cool. So let me try to recompile. Everything's compiling. And I've got unreachable, so that's precisely what happened in here. So I got it right. Yeah. So, So that means when we spawned an egg, spawn egg. So that generated x and y. Cell add is not empty. Oh yeah, I see what the fuck is going on. Sure. So we do cell add. God damn it, I see. And I suppose what I have to do now is just cell in and just cell egg like so. Alright, so that's the easiest way to go about it, I think. Though there is even easier, I can pre-push cell egg in here. I can kind of pre-push it in here. And then, so we do that, then we could consume whatever we have in here, return this thing, and then do int. There we go. So basically this turns into the value, into the point, into the arguments of the cell add in here. That's very interesting, actually. That's the very interesting way of thinking about it. No let bindings required, by the way. So, damn, that's a very cool way of thinking about it. Huh. Okay. There is some sort of a beauty in like stack-based languages, to be fair. Alright, so here, this is the value that we're saving. Here we're computing x and y, and then this is where... That's so cool. God. Huh, I really like that. Okay, so let's recompile the entire thing, and here's the egg. We've got an egg. But egg got destroyed. So essentially what I want to do now... Alright, so let's cut down on size of the snake, like around, maybe somewhere here. So this is going to be a small snake, right? So here is a small snake. And now, if we encounter, yeah, that's very cool. So here we encounter a cell in cell. If you encounter a snake, you say that you lost. If you encounter an egg, right, I think you should not delete this thing. Right. So you just add a new position and that is it. Otherwise, cell empty. Right, so cell empty. So this one has to be like that. We delete this stuff before trying to edit. That's the main difference, I think. Okay, so we take the player position and we step that player position in that direction. Then we look at what we just stepped, right? If that's a snake, if you stepped into yourself, that's it, you lost. If that's an egg, we just add this thing and that's it. And if it's something empty, we remove from the tail. So that way, every time we encounter an egg, we grow a little bit by one, which is cool, I suppose. So we can make the snake even smaller. What about like 3? And also spawn the new egg. Yeah, that's right. So spawn egg Right. It's cool. It's pretty cool. We can even think about it this way, right? We can always add this stuff, but depending on what we encountered, we either remove the from the tail or spawn a new egg. So that way we can sort of compress this thing a little bit. Man, I really like that in the middle of this code I can just say, okay, so this is cell now. I can just like switch case on cell, and I don't have to think too much. I feel much more productive with the lead bindings in Porth. It's amazing, actually. I've never felt so productive in Porth. It's just like it's an enjoyable language. Right. When I was implementing Porth in Porth was absolutely miserable experience. It was doable, but it was miserable. Now it's like magnitudes less miserable, right? At least I can just like give the elements on the stack names, and that's very cool. All right, so what we have in here, and let's take a look at them. Okay, so we've got a snake. We've got a snake. That's a snake if I ever saw one, honestly. That's a snake. We don't count the score. We can do that, but I mean, it's just like this is the core mechanic of the snake. And surprisingly, it was easy to implement. It was surprisingly easy to implement. I didn't expect it to be so easy to implement. All right. So the core mechanics is here, but it requires a little bit of polish, right? So yeah, so we just lost. But I guess we did it. Kind of poking. Yeah, it's pretty cool. We've got a snake, everyone. This is a snack. Epic snack. Huh. This is what you can do in Porth. But only if you know what you're doing, right? So you kind of need to know the platform you're working with, right? So you need to know about the terminals and stuff like that. But yeah. And we also had to extend the compiler to actually get it done, right? So because we didn't have the module stuff, right? But now we have it. Cool. All right, that's pretty pogue. I'm gonna do like cleaning up and committing after the stream. So does anyone have any questions? Maybe. Does the snake grow over time as well? As far as I know, in the classical snake game, snake doesn't grow over time. It grows every time you consume a fruit or egg, whatever that is, right? So yeah. Porth game dev indeed. Will you, once the language has matured, re-implement the compiler in Porth using the new features? I'm already using the new features in Porth, but not everywhere, right? As you can see, here's the lead bindings within the compiler, right? So I don't use them everywhere, but I'm just like slowly, incrementally like use them. So every time I need to implement like something new for Porth, I just go into the place where I want to implement the feature, and I just like refactor a little bit the code there to use new features. But I don't go out of my way just to go through all of the code base and like rewrite it. Like I won't do that because it's a waste of time. So yeah, I'm gonna be introducing new features, and I'm gonna be like adding them incrementally, because the size of the Porth is actually quite huge. That's the size of the Porth compiler. It's 5,000 lines of code, which is unnecessarily long. Like some of this code in there can be removed, so there's like a bunch of duplicates. So I would say that realistically it's around 3,000, right? So it's not really 5,000. So I can remove some stuff from there, but yeah. So that's pretty pogers. And I'm really glad how like relatively easy it was implemented. Like all of the necessary features are in there. So yes. You can remove opposite direction check, will die then. I can do a lot of things in here, I suppose. Port JS when? Soon. OpenGL. Working with OpenGL will require the, like linking with C libraries. We don't support linking with C libraries yet. Do you have buffered std and std out? Not yet. But it's relatively easy to implement, I think. I think it's relatively easy to implement. Do you think it would be easy to make ports to WASM compilers since both are stack-based languages? I don't think being stack-based does not necessarily make it easier to compile to WASM. I think the main challenge of compile to WASM is its blocks, right? So WASM doesn't have labels and jumps. So classical assembly, the control flow in classical assembly is basically you have a label and you jump to that label, right? So it is not like that in WASM. In WASM you have structured blocks. So essentially you denote blocks, begin and end, and instead of jump you have branch out of the block. And there are two kinds of blocks. There is a block that branches out to the beginning of itself, and there's a block that branches out to the end of itself. And using these two kinds of blocks, you can implement ifs and loops, right? So if you want to have loop, you use the block that branches out to the beginning of itself. And if you want to have if with else's and stuff like that, you branch out like outside, right? So, and usually when you have want to break out of the loop, you're going to have two blocks nested into each other. The inner one is going to be the one that jumps to the beginning, and the outer one is the one that's going to be jumps to the end. So that way you can branch out to the outer block. So you see, it's a little bit complicated. So, and if you have a bytecode or assembly that uses the label go-to paradigm, it would be extremely easy to compile that code into WASM into its structured blocks. So the difficulty compiling to WASM, in my opinion, is not whether something is stack-based or not stack-based. In fact, if you have just expression-based language, it is super easy to generate a stack-based one, right? So the main difficulty is WASM blocks, right? So I don't think it has anything to do with like stack-based or not stack-based. Can you spawn an egg on top of a stack? No, you cannot spawn on top of a stack because we check that you don't do that. Spawn egg. See? So we're generating coordinates in a loop, and in a loop we're generating new coordinates while the cell is not empty. So we're specifically looking for an empty cell, right? And we're only spawning an egg in an empty cell. When will there be a Windows support? That's a good question, actually. I think I'm gonna start working on a Windows support when I'm gonna start working on the mechanisms of abstracting out the standard library API, right? So essentially, things like puts, eputs, and some other things, right, to print things on the screen. I want to have a mechanism that allows you to swap out implementations of these functions, right? So, and depending on the platform that you're compiling to, you're going to use different implementations of these things, right? So on Linux, you're going to use the POSIX implementation. On Windows, you're going to use something else. On WASM, you're going to use the bindings that call to JavaScript or something. So when I started working on mechanisms that allow you to swap out implementations for library functions, maybe then I'll start thinking about Windows support, right? So, because essentially what I'll need to do, I'll need to re-implement the standard library for Windows. What about WSL for Windows port? People reported to me that port already works in WSL. Yeah, so... it's kind of broken. I didn't see any reports to my email. So if something is broken as WSL, like report to me. I can't get it to load. Okay, so there is a little bit of a difference between I can't get it to load and it is broken, right? So there's like a little bit of a semantical difference between not being able to do that and the thing actually broken. So anyway. Oh, you're talking about this, okay. I think the egg might be spawned where the head is gonna be. Let me see. I guess that is true. Okay. Thank you. You found a bug. That's cool. So, yeah. So first we step the player, then we take the cell. I will probably want to do it here, right? So this is going to be add that, then we take the cell in here. And yeah, so that should work now. So there is a possibility for this thing to be there, and that way you will. Okay, that's very funny. Oh, okay, so it's kind of difficult. I see. Okay, let's go back a little bit. All right, so I'm already a little bit tired right now, so I'll need to think about that. So I suppose we probably first want to add this thing in here. Right, so it has to be strictly before we spawn an egg. It has to be strictly here. But this one, it could be anywhere. Right, so I see the semantical difference. Okay, so okay, this is actually very cool because people are finding bugs in the code, right? That means people understand the code. That means it is readable. That's a very good sign. This is a very good sign. So that means whatever you see on the screen is readable enough that you can spot a bug in there. This is actually good. So. Yeah. Okay, good. So first time catching a live, I really enjoyed the VODs on YouTube. Thank you. I'm really glad that you enjoyed them. How would you start implementing linking against C libraries? Can't wrap my head around it. So first I would figure out how you link with C libraries using FASM, right? Because first of all, what we're doing, we're generating assembly, right? We're specifically using FASM, and I want to go with FASM as the main assembly. So I'll read documentation of FASM and figure out how you link with C libraries in FASM. And then, based on that knowledge that I gained, I would design the syntax of declaring external functions and also implement mechanism that links libraries and stuff like that. And also implement mechanisms of calling C functions, right? Because the call conventions of Porth are completely different from the regular C conventions, right? So we'll need to implement like a different call to those things, right? So yeah. So yeah, I'm not sure exactly. So first I need to learn how to do that with FASM, and then once I know that, we can go from there. All right, so I guess that's it for today. Thanks everyone who's watching right now. I really appreciate it. I hope today's session was interesting. I really hope so. And I see you on the next one. So yeah.